Hey guys, Mr. Jones here, and we are going to continue on with talking about and learning about imaginary numbers. Okay. In the last video, you guys saw me talk about them as they relate to the quadratic formula and kind of getting imaginary answers with the quadratic formula. Okay. But for these problems, we are just going to purely be dealing with imaginary numbers kind of on their own. Okay. So we're going to simplify a few more negative radicals, and then we are going to do some operation. Okay, but again, just reviewing, what's an imaginary number? What's it for? Why do we need it? So an imaginary number, again, we represent that with the letter I, okay, and we say that the unit I kind of is the same as the square root of a negative 1, okay? And again, because normally we can't take the square root of a negative, right? When we try to answer, like, what number times itself equals a negative 1, we couldn't say that, right? Not with real numbers, okay? But by using imaginary numbers like I, okay, we can kind of move forward and simplify these negative radicals that normally we would just kind of have to stop at and be like, okay, I can't simplify that any further, it's negative. But when I bring in the imaginary number, it kind of allows me to move forward with the problem and simplify it a little bit more, okay? So looking at these examples of this, okay, so if I said, okay, what's the square root of negative 49? And again, you would say, okay, normally nothing, there's no solution to that, okay? And it would be true to say there's no real solution, right? There's no real numbers that you could say that would be the square root of negative 49. But then bringing in I, we can simplify this. So what do I do here by bringing in I? Well, I separate this, right? Because the important part here is the negative 1. That's what I is equal to. So I kind of want to rewrite this as the square root of negative 1 times the square root of 49. Okay, that's equal to this because, right, negative 49 is negative 1 times positive 49. And I can separate this out, okay? So I can kind of separate, I can kind of separate the negative from the number, and then that'll allow me to reduce it and simplify. Okay, so again, the square root of negative 1, that's what I is equal to, so I can rewrite this as I times, and then the square root of 49. What times itself equals 49? Well, that's just 7, right? So I can say, okay, the square root of 49 simplifies to 7i, is what I would say for that. Okay, 7i. Now, it's easy when we're dealing with a negative perfect square, right? Because we don't have to worry about anything, right? It's just the square root of 49 is 7, and I'm done, okay? But then when I look at numbers like 2 and 3, right, these are not perfect squares. So I'm going to have a little bit more work to do to fully simplify these. Okay. So if I do the square root of negative 50, if I want to simplify that, okay, again, I start off by saying, okay, that's square root of negative 1 times the square root of 50, okay? And then, okay, the square root of negative 1 is I, and then, but I run into an issue here, right? Because the square root of 50 would be like 7.0 something, right? So I don't want the decimal, okay? But I can simplify this, right? If you remember from Algebra 1, you can simplify these radicals, right? Kind of like reducing a fraction. You can reduce this by pulling out a number, a bigger number out of the radical, okay? And I have a video of that. If you need a reminder of that, I'll link that to my page here as well. And if I find a way, I'll link it to this video. I'll put it right here. I don't know if that's going to work or not. Anyway, so square root of 50, okay? Again, you guys might remember, I think, okay, what times a perfect square equals 50? And so I think about all my perfect squares, right? 1, 4, 9, 16, 25, 36, 49, and so on, right? So I think, okay, which one of these multiplies to get 50 and 25 does, right? 2 times 25 equals 50. So I can separate 50 into the square root of 2 times the square root of 25, okay? And then write the square root of 2. That's not a perfect square, so that's going to stay in the radical. But the square root of 25 is going to be 5, right? So I can rewrite this as I times, right? I'll flip these around. The square root of 25 is 5. And then the square root of 2, that just stays in there, okay? So then just writing this, finally writing it, it's just kind of lumping the 5 and the I together, just like how we do with a variable, right? We kind of write the number first, then the I. So 5i times the square root of 2 would be the simplified version of that. Okay? Okay, cool. And then negative 60. Okay, this one's going to be even tougher. Okay, again, I started out the same way. When I see that it's negative, there's not going to be a real solution to this, but I can simplify it by saying, okay, negative 1 times 60, right? And this negative 1 is going to be just an I, and I'll kind of leave that to the side. Okay, but now 60, okay, that's a number that's tricky. Okay, so again, I think about these numbers, and I think, okay, do any of these multiply to get 60? And it might take a while, but 4 actually does, okay? And again, if you didn't know that 4 times something is 60, you could always divide each of these. Do 60 divided by 1 is going to be 60, but 60 divided by 4, 60 divided by 9, 60 divided by 16. And what you want is a whole number answer. If it's a whole number answer, that means you can separate it, okay? But if you get a decimal, that means it's no good, okay? So if you did 60 divided by 4, you would get 15. So kind of reversing that, 4 times 15 is 60. So that means I can split it up as the square root of 4 times the square root of 15, okay? And what's the square root of 4? The square root of 4 is 2, right? So I can simplify that. I can say 2, but then that 15 stays in the radical because that's not a perfect square and it doesn't have any perfect square factors, okay? So then writing this answer, finally, it's going to be 2i times the square root of 15 would be how I reduce that and simplify, okay? And now we'll get into these complex number operations, okay? So these groups of terms, right, like kind of like combining like terms, but they have an I involved. So again, this combination of real numbers and complex number, or real and imaginary numbers, that group is called complex numbers, okay? So how would I do this? How would I simplify this or find the sum or difference between these groups? Okay. Well, but I basically already said it. You would combine like terms. Okay. So between your two groups, okay. And again, it shows the parentheses just to kind of show like, okay, this is the one group, this is the other. But when you actually go to add them, you don't really need your parentheses. So you could think of this as one big group. And I can just drop off the parentheses because this is adding. I know I'm adding these two groups because there's a plus in the middle of them, okay? When I go to subtract the groups, I'm gonna have to do one more step before I can drop the parentheses, okay? And I'll show you. But when it's adding, it's nice. I can just drop the parentheses, think of it as one big group, and just combine my like terms, okay? So here, right, I think, okay, my whole numbers, my numbers without the I, okay? I have 2, and I have positive 1. Okay, so positive 2 plus 1 is 3, right? So just 3, that's a whole number, a real number, okay? And then my imaginary numbers, I have positive 3i plus 1i, and you'd add those just like you would add variables, right? 3x plus 1x would give you 4x, right? In the same way, it's going to be 3i plus 1i gives you 4i, okay? It's like somebody with glasses, 4 eyes. Don't call them that, that's bullying. But anyway, yeah, so that's how we would add these, okay? And then 5 and 6, subtracting, okay, just one extra step, okay? So what I have to account for here is it's saying this group minus this whole group. So everything in the second group is being subtracted from this first group, okay? So here's how I can account for that. I can do what I call distributing the negative, okay, which means basically I'm going to change both of the signs in my second group to be opposites, okay? So like this is positive 10 in the group, and I'm subtracting it, so that would be minus 10, okay? And then if I distribute the negative here, negative 7i, I could change that to plus 7i. The reason I do that is because, right, if I subtract, this is negative 1i, and I'm doing minus negative 7i. Think about minus negative. Minusing a negative is the same as adding, right? So when I change the sign right away, it helps to eliminate a lot of the mistakes that kids often make, right? Because it's easy to miss that you're minusing this negative, okay? But when you do it this way, you can just deal with it right away and you don't have to think about it anymore, okay? And then this first group does not change, right? Because this is the group that I'm starting with, and I'm taking away the second group, okay? So I distribute the negative to the second group, and now it's so similar to what I had up here in number 4, and I can just combine my like terms, okay? So same idea. I have two whole numbers, right? 6, positive 6 and negative 10. Okay, so I think 6 minus 10 gives me negative 4. Okay, and then negative 1i plus 7i. So negative 1 plus 7 gives me positive 6i. Okay, one more here, and then we'll get into multiplication and division, like I said. So this one, again, you see that it's subtracting. That's the first thing you want to look for with these sum and difference problems is it's being subtracted. So I distribute that negative to just the second group, and I change those signs. So it'd be negative 8 plus 9i, okay? And then this first group just comes right down. You can get rid of the parentheses. And now it is one big group, and I can combine them, okay? So I have my two whole numbers, so 8, positive 8 and negative 8. 8 minus 8 is 0. They would cancel, okay? So you could write the 0 there, but there's no point because it's not going to affect anything. But then positive 9i plus 9i. So 9i plus 9i gives me 18i. And that is it, okay? That's how we would subtract those, okay? So there we go. There's some sum and difference problems with complex numbers. Again, I'll erase this and we'll do some multiplying and dividing too, and then we're all set.